Hi, in this video we solve this problem as it relates the application of unit analysis in physics. This question says a sphere of radius A moving with a velocity v under streamline conditions in a viscous fluid experiences a retarding force F given by F equals KAV, where K is a constant. What are the units of K in terms of base units? So to solve this, we quickly write this retarding force formula. This is KAV. So we shall show that the SI units of K in terms of base unit is that K is having this SI unit kgm by 1 s by 1. So if you want to know how this is possible, you stay tuned. This is Neselifa. So what we do quickly now is we make this K subject of the formula. So we are told here that K is what? A constant. So what we do is I will say F upon AV. This A is not acceleration. Do not mistake it. This is radius, while v is what? Velocity. So what we do now is the unit of force is kilogram meter per second square, while radius is just measurement of length. This is radius. So this is meter and this is velocity. Velocity is meter per second. So I'll write it like this. This is meter per second. So this cancels this cancels this. So what happens is that we have kg, meter here going up, we have m by 1. This is x by 2. Of course, since we go up again, law of indices, we have this. So that finally we have that this is kg m by 1 s by 1. So this is kg m by 1 s by 1. So this is the units, the SI units of K in terms of its base units. K m by 1 s by 1. Subscribe for more updates.